So let's look at this question here, which is on parametric equations and also graphing techniques. So you're given a curve which is defined by this thing parametrically from 0 to 2 pi. So what I would suggest is actually just key into a calculator and check, as in just have a sense of how the graph will look like. So just go to parametric curve here and just key in. All right. So now the first thing is just key in for the x and y. So this is 5 over 2 cosine 5 over 2 cosine theta, so cosine t, and after which you have got 3 over 2 sine theta, so this is 3 over 2 sine t. Okay, so this is 1 and this is 2. Then what we need to do is actually just go to the window and we're going to set this as 0 to 2 pi. There you go. Graph it. And you get this value here. So just make sure that it's 0 to 2 pi, which is already is a standard one. So you see that this is sort of like an ellipse. So you could actually just zoom square it if you want to. So it looks then zoom in. All these adjustments it will help you in your examination, right? So just make sure that you can adjust all this properly. Now, once that's done, find the coordinates of the actual intercept algebraically. I think that's pretty okay. What we need now is actually just solve this part here algebraically. So just let x equals to 0 and let y be 0, right? So to find the y-intercepts, what we need is actually just let x be 0. So this case here, 0 equals to 5 over 2 cosine theta. And cosine theta equals to 0, and theta would just be pi over 2. Sorry, it starts with pi over 2 and 3 over 2 pi. Okay, so it's 90 degrees and 3 over 2 pi. We could just check your value here. So this is like you just trace. So you put pi over 2 in. That will be this here, and also 3 over 2 pi. You will get here. Okay, so there you go. Once you're done with that, so zoom pi over 2, trace pi over 2. Okay, it's there you go. I'm not sure why this. Yeah, just zoom in and zoom square. Yeah. Okay, so this is. So when theta is pi over 2, we could actually find what is the y. Y would just be, just substitute this in 3 over 2 sine pi over 2. There's 90 degrees, so theta is pi over 2. This would just be pi over 2. Sine 90 is 1, so this is 3 over 2. And theta is 3 over 2 pi. Y equals 3 over 2 sine 3 over 2 pi, that will be negative 3 over 2. This is negative 1. This is, yeah. So the coordinates of the actual intercept. So hence, we already have got x is 0, 3 over 2, and 0, negative 3 over 2. Okay, that's pretty okay. Then after which, we're going to look at the y, which is equals to 0. And basically, y equals to 0 will give us 3 over 2 sine theta, which is actually 0. Then theta would be, sine theta would be 0. And sine theta 0 would just means that theta is 0 and pi. Alright, so that's 0 and pi. So when theta is equals to 0, y is 0 obviously. So x is equals to 5 over 2 cosine 0, which is actually 1. So 5 over 2, and theta equals to pi. X equals to 5 over 2 cosine pi, which is negative 1, so negative 5 over 2. So the curve here will just be 5 over 2 comma 0, and after which is minus 5 over 2, 0. Okay, so that's how we do the first part. Obviously, you could check your answer by just clicking in pi, trace as pi, and you can check this negative 5 over 2. And obviously, and also 0, so trace 0, you get that value there. Okay, so that's how you use a calculator to check. Let's look at the subsequent part, which is to show that the Cartesian equation of the curve is x squared over 2y squared. I think that's pretty okay. What we need to do is actually to combine these two together, these two equations here. So the first thing is to write how do we connect sine, cosine, and sine theta together. We're going to use our infamous equation here, which is actually cosine square theta plus sine square theta equals to 1. Okay, your whole goal is to make sure that you need to get rid of your cosine theta and sine theta. So this is a connecting equation here. So from this value, I know that this cosine theta is actually 2 over 5x, and this sine theta here, quickly do is 2y over 3. So I could just substitute this in. So 2 over 5x, right? So this is cosine, this is 2 over 5x square plus sine, which is 2y over 3 square equals to 1. And once this is done, we could just put this as 4 over 25 x square plus 4 over 9 y square equals to 1. And after which we just divide both sides by 4. I think that is okay. Just divide both sides by 4. And this will be 1 over 25 x square. Is x square over 25 and plus y square over 9 equals to 1/4. Okay, maybe I should just write now since x equals to 2/5. So cosine. That's how I do this question here. I think it's pretty okay. Let's look at the subsequent part. Alright, the last part. So as for the last part, show that the distance of point P to the curve with parameter P to the point 20 is this value here. So you want to find the distance from the point P with parameter P. This point here, if it's parameter P, this point P would just be, this become P because that is the parameter there. When parameter theta equals to P, this means theta equals to P. So point here will be 5 over 2 cosine P, comma 3 over 2 sine P. Okay, and you want the distance to this value 20. Okay, so how do we do that? So this case here, what we need to do is actually just part 3. Point P would be point P is when theta equals to P. So x will just be equals to 5 over 2 cosine P and y equals to 3 over 2 sine P. So this is a coordinate. I do not know where is the coordinate here, but let me just illustrate this for you. From this graph here, you know that actually, let me just copy this down. So this graph here, we have a point P. I'm not sure it's a P, but it could be any point on the line, on the curve. So this would be P. P would be 5 over 2 cosine P. And over here, y equals to 3 over 2 sine P. So you want to find the distance from this point to this point here. So this is 20. Okay. So the distance between these 2 points, we'll just use, we're going to use the distance formula. Will just be square root x1 minus x2 square plus y1 minus y2 square. That's about it. Okay. So the distance between these 2 points here will just be P distance from P, which is actually 5 over 2 cosine P, comma 3 over 2 sine P, to 2 comma 0 would just be square root 5 over 2 cosine P minus 2, x1 minus x2 square, and plus 3 over 2 sine P minus 0 square. Great. So once this is done, what we need to do is actually just expand this out. So this will be 25 over 4 cosine square P minus 10 cosine P plus 4. Then subsequently, this will just be plus 9 over 4 sine square P. Oh, that's all. 0 is good. I like it with 0. Okay, great. So this is it. But obviously it looks terrible now because everything is just in a mess. I would suggest we just get 9 over 4 out from here to get the 1 out. So I'm just gonna take let's say 9 over 4, 25 minus 9 will just be 16. So 16 over 4 cosine square P plus 9 over 4 cosine square P. So I split this up. This over here to 25 plus 9 is 16, right? So this case here, once it's done, we're going to put 94 sine square p, then minus 10 cosine square p plus 4. That's pretty okay. Then the reason why is because I want to merge these two up. These two, if I would merge it up, will be good job, well done. Okay, so that is these two is actually this is just a manipulation. So I don't think this is the only way to do this. This is just what I'm thinking. So you can just use whatever method you feel that is good. So I'm gonna do this part, and this will be 9 over 4 times 1 minus 10 cosine p plus 4. Okay, so 9 over 4 will just be 25 over 4. It's a lot of things to write. Plus 25 over 4. Okay, then what we're going to do next is actually just I'm just gonna change. I'm not sure. I could just multiply by 4 throughout. So this is 16 cosine square p minus 40 cosine p plus 25 over 4. That'll be much easier. Then I'm gonna try and see whether I can factorize the top part and hope that there's no careless mistake. And from this juncture onwards, if you have careless mistake, it's going to be very clear. Polynomials degree of 2, and this will be 16 minus 40 and 25. And there'll be 5 over 4, and there you go, just 5 over 4. So that's good. Very good. So 4 cosine p minus 5 square over square root 4, which is 2. So this case here, would it be a positive or negative? Oh, it's positive. So this case here will just be 1/4. Is that it? Great. Great. Okay. Oh, something is wrong. Y cosine square will be negative. Oh, okay. Let me see first. So obviously I missed out something. This one could be plus minus. We need to reject 1. That is the problem there. Let's see how. This could be plus minus, okay? Because you square root it. You're not sure whether this will be 4 cosine p minus 5 or negative 1 over 2 4 cosine p minus 5. But obviously, what we need now is a length which is actually what do you call it? We need a length which is like we need a length which is positive, right? So what we could do is actually just look at the range at where we are going to look. So p is between 0 to 2 pi. Yeah. So p is between 0 and 2 pi. Then after which we just cosine p both sides, and cosine p. Cosine p both sides will just be cosine 0 will just be 1, and cosine 2 pi will be negative 1. And essentially, for cosine p, you need multiply by 4 for 4 cosine p. Oh, sorry, this is not how you do it. Hold on. My bad. For this inequality here, this is really bad. So from p to 2 pi, so I think just draw the graph. That will be the easiest to understand what's going on here. So here we'll be dealing with 0 to 2 pi. So this case here, for cosine p, so we have cosine which is from 1 to negative 1, right? Here's 2 pi, and this is negative 1, and this is pi. So the thing now is you want it to be this is pi, and this is pi over 2, and this is 3 over 2. Okay. So we gotta know that actually this case here we want it to be positive. So 4 cosine p minus 5 as opposed to 5 over 2 minus 2 cosine p. So this is 2 graph here. So this is 2 cosine p minus 5 over 2, or minus 2 cosine p plus 5 over 2. Okay, I think the easiest way is just to plot the graph. Then you will be able to see that actually which will give you a positive value. If you look at this part here, 2 cosine p plus 5 over 2, this would be, let me just plot it out for you, then probably this will help. This is 2 cosine p, let's say 2 cosine p minus 5 over 2, and after which you have negative 2 cosine p plus 5 over 2. Okay, you realize that 1 will give you a positive graph. So the one above will give you a positive graph. So the red color will give you a positive graph. Okay, so this part here, we reject this part, reject, as distance is more than 0. Okay, so hence this will just give us negative cosine p plus 5 over 2 shown. Okay, that's how you do it. Okay, after that we are told to find a similar expression for minus 2 to 0. So is this minus 2, 0 will be here. Okay, the hence part, let's look at that. So the hence part, we are looking at minus 2, 0 here. So what we could do is actually the same thing. We are actually looking at substituting 2 as minus 2. So what we need here is a plus instead of a minus. Is there a way for us to find? You have this distance here. This is not 90, sorry. You cannot assume it's 90. It's not, because it is 90. Unless we can find a gradient here. Whew. So the last part, minus 2, 0 is here, negative 2, 0. So what happens is this change to negative 2. So this will be plus over 2. So the distance, between p and negative 2, 0, everything is the same actually, except for these changes to positive 2. So this whole thing, this will be a plus 10 cosine p, right? So this is 10 plus cosine p as well, because if this is, so this is what's going on. So this is 5 over 2 cosine p, 5 over 2 cosine p plus 2 square, and plus 3 sine p square. So plus 3 over 2 sine p square. That's okay. Then what we need to do is actually just change the 10 cosine p out. So that will be this, if you were to do everything the same, with cosine square p plus 10 cosine p plus 25 over 4. Okay, then if you were to bring the 4 out, that will be 16 cosine square p plus 4d cos. Actually, you can skip step. I'm just going to, this is just me showing how, so this will be 4, 40, and 25, and that will be, whoa. Okay, let me see first. Is that correct? 440 plus 25, 440 plus 25, 440 plus 25. So I came wrongly. That will be similar. This is 4 cos p plus 5 over square over 2. Okay. Similarly, this will be 4 cos pi. So it will be half 4 cosine pi plus 5, or negative half 4 cosine pi. Okay, we just need to find out which is actually a positive value. You have a plus or minus because of this square here. Okay, so we just need it to be positive. So just key in calculator and see the graph that it gives you, which is a positive one, right? So this case here, what I'll get is half. Okay, so this case I could get 5 over 2 plus half p, or it's the same actually. a negative 2, 5 minus 2 cosine pi. 5 over 2 minus 2. Okay, so it's sort of like the same but different, just need to change this. And this will be plus, right? Okay, so this is 2. Yeah, correct. So I'm just going to graph it. I'll get the positive, which is the blue color one. So the blue color will give me 2 cosine. Actually, it's quite clear, it's just this. So reject. As distance is more than or equal to 0. So hence this is just... Okay, so this is how I do this question here proficiently. Now, any question at all, please let us know. Keep practicing and I'll see you in the next question.